Hello everybody, and welcome to another math tutorial video here where we will be focusing on multiplying with rational exponents. And this is on IXL M2 in case you need a little bit of help with that. So let's look at this one here. Let's get right into it. So we want to simplify, and that's pretty much going to be what the directions on all these are, so I won't be rewriting that every time. So we have 3 to the 1/3, and man, my stylus really is not being the nicest. All right, 3 to the 1/3 times 9 to the 1/3. So basically, we're doing the cube root of 3 times the cube root of 9, but we're not going to worry too much about that. So one thing I should notice here is we have same exponents, but we have different base. So if this is the case, then we're going to group. We're going to group it, and then we're going to solve it that way. Okay, so anytime I have the same exponent, different base, I'm going to group. So we're going to group the 3 and the 9 together. So I have 3 times 9. I'm grouping them in a parenthesis. And then all that's going to be to the 1/3 power. So that's going to be 27 to the 1/3. And 27 to the 1/3. If you need help with that, check the previous video on L2. But that should be 3 because the cube root of 27 is 3. It is a perfect cube. So let's look at another example. So on this one we have 128 to the negative 2/3. Ooh, they're throwing that negative exponent at us. They're trying to freak us out, but we're not going to let that happen. So 128 to the negative 2/3 times 4 to the negative 2/3. So, well, same as the last one. We have a different base, but we have the same exponent. So, we're going to group. So I'm going to say 128 times 4. Whoa, that looks kind of weird. And then we have to the negative 2/3. Okay, so 128 times 4, 256 times 2 is going to be 512. Of course, you can use a calculator. But I'm just doing this in my head here because I'm crazy. And so we have 512 to the negative 2/3. Okay, now here's the thing. I want to have this as a positive exponent. We cannot have a negative exponent in our answer. But of course, this will probably end up without an exponent anyway. So when I do this, I'm going to put it as, to make this a positive exponent, we're going to put it at the bottom. We're going to, if it's on the numerator, I move it to the denominator. If it's on the denominator, I move it to the numerator. So we're going to have 1 over 512 to the positive 2/3. Okay, and then when I do 512, well, I know 512 to the 1/3, because it's a cube root, it is a perfect cube, would be 8. So basically I do 8 squared, which should be 64. But if you weren't confident in doing that, you just type it into the calculator, just as I showed you in the last video. And you get 64 that way. So I'm going to have 1 on the top still over 64. Man, my stylus has been crazy. So yeah, 1 over 64. All right, and so not bad at all, is it? Well, let's try another one. So we have on this one. So on this one, let's do one with the same base. So let's say that I have 11 to the negative 1/2 times 11 to the negative 1/2. Okay, so on this one, we have the same base. So if I have the same base, basically on this, I'm going to just add my exponents. This is the same way as if when we did exponents earlier. This is basically just my power rules, my exponent rules. So if I have the same base, I'm just going to add my exponents. That's really all I'm going to do. So on this, I'm just going to have 11. My base stays the same. So, okay, this is frustrating. So my base is going to stay the same. So my 11 is still going to be my base, but I'm going to do I'm going to do negative 1/2 plus negative 1/2. Now, if you already know that you don't really need to write it that way, I'm just showing and breaking it down as simply as I can. So I know that's going to be a negative 1/2 minus 1/2, so it's going to be 11 to the negative 1 power. Now, just like in the last example, I don't want any negative exponents, so this is going to be 1. I'm going to move the 11 to the bottom. So it's going to be 1 over 11 to the first, which is basically just going to be 1 over 11. So that would be my answer on that one. Okay, and then let's do one with some variables. So let's say that we have y to the 5/2 times y to the 1/2. Well, same rule as the last one. I have the same base. My base is y. So it's going to be y to the 5/2 plus 1/2. Don't let the fractions intimidate you, y'all. You do it the same way. Basically, I'm adding halves together. So if I have 5/2 plus 1/2, I'm going to have 6/2. So that's going to be y to the 6/2, if my stylus would work. So it's going to be y to the 6/2. 6 divided by 2 is 3. So my final answer is going to be y to the 3rd. See, that wasn't that bad, was it? All right. Let's do one more, and then I think we're probably pretty good on M2. So let's do w to the negative 1/2. Ooh, we got another negative exponent times w to the negative 2/7. Okay, so same rule as the last few problems here. We have the same base. My base is w, so we're going to do w, and then I'm just going to add my exponents because I have the same base. So w to the negative 1/2 plus negative 2/7. All right, on this one though, I'm adding halves and sevenths. They're basically not the same thing. So if you go back to 5th and 6th grade math a long time ago, when we were adding or subtracting fractions, well, we have to get a common denominator. So what I'm going to do here is we're going to do negative 1/2. So let me just pick a different color. Let's see. I'll do that. Let's do blue. So I'm off to the side. I'm going to do negative 1/2, and then minus 2/7. Okay, this really is being frustrating. All right. So my common denominator, I'm thinking, what number will 2 and 7 both go into? Well, I know they both go into 14. And one little trick here that when I used to teach 6th grade math, a little trick I noticed was that I always explained to them was that if you have a prime number, 2 and 7 are both prime. Or a lot of times if you have an odd number, in general this will work, but you basically could just multiply the two denominators. So that means 14 is going to be our LCD. So I'm going to get 14 on the bottom here, I got to multiply by 7. So I have to do it on top and the bottom. And on this one, we're going to need to multiply by 2. And you got to do it on the top and bottom. Basically, I'm not changing those because if I multiply by the same thing on top and bottom, it's still going to be, I'm basically just multiplying by 1. So I'm not changing it. So when I do that, I'm going to end up with negative 7 over 14, which is the same as negative 1/2, minus 4 14ths. So negative 7 minus 4 gives me, as my final answer, W to the negative 11 14ths. Well, actually, that's not my final answer because we have a negative exponent. So we got to fix that. And how do we fix it? Well, really simple. We're just going to move it to the bottom. So it'd be 1 over W to the positive 11 14ths. And that's it. Alright, so if you have any questions, just email me or whatnot, all that good stuff. Hope you have a great day, and good luck with this, y'all. You got it.